So, welcome to this metrology, measurement and metrology subject of second unit. Here, I have taken some in 10 to 12 questions to discuss about the unit 2 mark. Unit 2 is completely based upon this flatness measurement. So flatness is measured. So, flatness, what we see is different. We have to measure that flatness also. The roughness of the flatness is measured. For that, we have some tools also here. This we need to explain here. So let us say what are these experiments which are useful to measure this flatness and all in this unit one. I will be covering here. So first question I am taking define what is this flatness measurement. The flatness measurement is what is flatness first of all. Flatness is the how do you define it? Flatness is the degree to which a surface lies in a single plane. The surface is tested in a single plane only, not different planes. You cannot go there. It is an important geometric tolerance. So there is a geometry. Geometry means lengthwise or breadthwise. You have to go on to measure the flatness. It is measured using the precision instruments, and also it ensures proper fitting is there or not, and the proper functioning of the machines, and also it is used in machine components and surfaces. So here you can see this is the drawing. This is the flatness is there. You can measure this one. So flatness outer it is 18.5, inner to inner it is 17.9. So that is the way of measuring the flatness of a surface. Outer outward measurement and inward measurement is shown. So here also you can see this roughness. You can see this is 0.25 white tolerance is given here. So this is if you seeing in the microscope, it is not some ups and downs are available in this rectangle figure. But here you can see it is a very flat here. But here you can see that flatness is measured the inner flatness and outer flatness. Here some tolerance is given for this zone because it is having some up and downs. So to calculate this up and down, to fit this up and downs, we can leave 0.25 tolerance. In this case, it is exactly fitted. So the machines can be easily fitted. So that is the explanation of that one, first question. So what is a straight edges? Straight edges or surface plates we can tell. So this is a surface plate which is used to measure the straight edges, especially in the construction of walls and buildings. In the civil construction work, we need all the instrument to measure the wall is in a straight position or not. The straight edges are used to check straightness of a surface, how much straight the is there, the floor is there, or a wall is there. So surface plate provides a flat reference surfaces. So flatness we want. We don't want some rough surfaces. We want straight and straight edges and also straight plate we want. Edges also, these edges also we want to make straight. This flat, this also we want to make surface also flat, perfectly flat. This is an instrument which is made up of cast iron or granites. So this is also used for inspection and marking. You can you can mark and build and inspect like this. The basic tools for flatness checking. This is the basic tool for measuring the flatness of floors or of walls in a concrete or machine system. So third question we are going to take what is the optical flat? So what do you mean by optical flat? Here is the flatness measurement by using optics here. So this made of high quality transparent material. These are the convex surface. This is convex surface. This is you can see leftward. This rings are provided here. The rightward rings are provided here concave. This is flat surfaces. So lines are parallel lines are here. So this is three types of flat optical flats which are used for measuring this flatness of a surfaces. These are generally instruments made up of high quality transparent materials. So these are made up of high quality transparent materials. These are used with monochromatic light. It also produces interference fringes. So for interference fringes also, the light is coming from different sources will interfere with each other and form fringes. So the fringes indicate flatness errors. These fringes indicate flatness errors also will be there, which will be eliminated. High precision measurement methods are used. So high precision measurement methods are used in this to measure the flatness. So here, you can see this is a flat surface is there. This flat surface, the light is coming from a source, yes, and it is touching and it is going outside here. You can see here. So one green light is coming, it is divided to one green light and one red light. One is reflected one is not reflected one. So here also one source S is coming and it is reflecting at point E and it is going out in the form of two surfaces. This is a theta, you can measure this is a theta. So in this way we can measure the flatness by using optics. Optics flatness we can use. Light is used here, monochromatic light. So what is a colorimeter or autocolorimeter? So autocolorimeter is also is something which is used to light is used to measure the object. So it is also light is used to measure the instrument here. Here here, what is happening is optical instrument for measuring small angles. So small angles are going to be measured here by using optical instrument. Uses reflection of light beam. It uses the reflection of light beams. So it is also used to detect the slight surface deviations. The slight surface deviations also can be measured here. They are very high accuracy. We are having more accuracy because we are using optical measure. Light is used for angle the measuring. So used in the precision alignments also. You can see that there is a precision alignment should be done here. So here in the diagram, principle of autocolorimetry is shown here. There is a reflector mirror kept here. So this is a object which is giving out the object which is giving out the lights. These lights are going and reflected on this mirror and they are coming with some theta and are getting together here at the point here. This is the image is formed below this one. So below this one, the image is formed. The distance between this is x is equal to 2f. The distance is between 2f. What is the focus point is down 2f distance. This is a calorimeter lenses are used. That is what it is called as calorimeter or collimeter. The object light is traveling to this one and going straight and reflecting the reflect mirror and coming back and again forming the image, same image here at this point at a distance of x is equal to 2f. This is a autocolorimeter. I am also telling you this is used by light beam on surface deviation. So I am going to take the fifth question. What is happening to the fifth question is what is a interferometer? What is a interferometer? Interferometer is nothing but it uses the interference of light waves. It uses the interference of light waves. It measures a very small surface deviations. Very small surface deviations can be measured. It produces fringe patterns. There are fringe patterns. Highly accurate method. It is used in the laboratory and optics. So interferometer means you can see here infrared infrared is used here. Infrared light is coming here. There is a silver plate kept here at an inclined position. So this is going and hitting to this one, hitting this surface and hitting the surface and these infrareds are traveling from here. You can see this line going to a stationary mirror. It is kept here, then from the stationary mirror again it is going to this moving mirror and again coming to this one again coming to this silver model and then they are going and detected here. So what is the in this the distance of this moving mirror, the distance of this fixed mirror, it is red in one line and then it is coming to this detector. It is shown in the detector display. The sample is kept here. Okay, the sample is kept here. So this is the why it is called as infra means infrared lights are used. Infrared light is projected on an inclined surface. The lights which are evolved from this, they are going and touching the stationary mirror and also they are coming back. They are going and touching this moving mirror and coming back and giving a the detector is detecting, noting the values. That is what it is called as infrared. Now, sixth question is what is the surface roughness measurement? Here comes the roughness models. Roughness means, see, this is a benchmark, which is a very perfectly surfaced model here. Here, what is the meaning of this roughness means surface roughness means indicates irregularities, which indicates irregularities of the surface here. So affects friction and wear. It will going to affect the friction and wear. It is also important for quality control, measured using special instruments, different from waveness. Ma. So waveness is different, ma, like waves on the surface, which we can see in the microscope meter only. Here it indicates a surface roughness measurement. This is a irregularity of the surface. It is a friction of the surface, and also it is measured. Special instruments are used. Now here you can see, ma, what is the surface roughness versus waveness. What is the difference between waveness and surface? So surface is small values, fine irregularities, very small irregularities are there. And what is the waveness is? Waveness is Waveness is larger, widely spaced irregularities. So very wide irregularities are waveness mark. It's very small are called as surface roughness. Roughness due to machining, due to roughness due to machining, waveness due to vibration or deflectors. Waveness is due to vibrations mark. It is formed. Roughness due to machining. While you are machining, the machining is not done properly mark. There will be some ups and downs. It is called as roughness. Waveness is due to vibrations. We can see some change in the dimensions. So both affect the surface quality. So here you can see this is the surface mark. If you are going to study in the microscope, some layers are there, parallel lines are there. This is a waveness height, waveness spacing is there. So these are the waveness mark. So ups and downs in the surface. So we can see under microscopic mark. So what is the CLA? So in order to measure all this mark, you have to take average. So how many lines are there? You will take wavelength, height you will take, and spacing you will take, you will calculate. So in that we are having a CLA method, that is central line average mark, RA value. What is CLA, central line average, RA value? So nothing but this up is there, down is there, up is there, down is there, up is there, down is there. Total length L is there. It is a main line is there. So area A1, A2, A3, A4, A5, A6. All the areas are averaged. They are taking the average and divided by line L. So this is called as RA, means taking a average. Average we are taking about all the areas in this way. So it is a average deviation from mean line, mostly used for parameters, represent surface finish, easy to calculate and interpret, expressed in micrometers. So micrometers expressed this one. So again, other than measuring RMS value of a flatness, so this is the root mean square of deviation. The root mean square of deviations is RMS value, more sensitive to peaks and values, higher value rather than RA. So in average, what you are getting here, we are doing root mean square deviations are taken, peaks and values used for precision articles. So here also we can divide this one 2 3 4 and 5, 6, 7, 8. So here also area A1, A2, A3, A4, A5, A5. This is between mean line is there. So here also you can take all the root mean square of the deviations. So this is root mean square of this deviation, root mean square of deviation. All you will take. This is the peak and this is a valley. Peak means height is there and valley means down is there. So peak value. All the peaks are taken. 3 peaks are there. 4 values are there. So you can just you have to take a square and mean. Square and mean of that. You have to do it here. So next, what is happening? Next question. You are going to take define Rx. Define Rx. You are going to value. Okay. What is RZ value? Not Rx, sorry. So average of peak to valley heights. So all the peaks P1, P2, P3, P4, P5 and all the heights H1, H2, H3, H4, H5 you are going to take. Here also you have value V1, V2, V3, V4. So downside all we are taking, upside we are taking, we are measuring the heights of them. So this is the average of peak to valley heights. So valley heights is given here. So what is the peak heights? P1 by H1, P2 by H1, like that you can measure maximum roughness. So this roughness is perfectly measured here. It is based on selected sampling length. It is measured on this length. This length is there. So also used for functional surfaces. Functional surfaces. Mixed. So the next question is you are going to take ma define methods of measurements. What is the measurements? You can measure in the two forms, profilography and tail surf. So what is the tail surface? Tail surf difference between both of them. What is profilograph records surface profile graphically. So perfect, you have to measure the surface ma by using their profile. So, tail surf uses stylus ma to trace the surface. So, some sharp material is used, like a pen material, like one. They are also both are converting the movement into electrical signal. Very very important. The readings are given in the form of electrical readings. Also, they are displays the roughness values. They are high accuracy instruments. These are the high accuracy in measuring the roughness ma. So here you can see ma, this is measuring roughness ma. This style is it is connected here to this one. This movement are recorded by this one. This is giving the converting them to both the sides electrodes here. Electrical signals are recorded here and here ma. So this is totally an instrument which is continuously touch with the surface ma. The surface waves you can see here, rough waves, small waves, peaks and values. It will touch all the peaks and values. It will do the average ma. So as we have done before, we are having three types of methods. So peaks and values you have to do average and mean square, and also you are having a that heights. Three types only measured for the roughnesses. Last question, 12th question. What is BIS symbols surface roughness? The standard symbols used in the drawings. Ma. So these are the standard standards are used here. So you can it is measured. Ma. Here you can measure 12.5 surface roughness. This is 12.5. This is angles are measured here. This ball is kept here in order to measure the angles. Ma. This is also used to measure the angles. This is also used to measure the square of this one. So this is all surface finishes and roughness. So BIS symbols. Ma. So you can measure by this only, not others. It indicates a required surface finish. It includes roughness, shows the machining requirements, ensure uniform manufacturing standards. So definitely they are used in the machines. Ma. So till here I have covered 12 questions. 12 questions I have covered important questions which are useful for this one. So they have to be studied for the second question. So maximum three types of RMS, RA and CLA methods using the rough surfaces. So mainly this one will come here, important questions. And autocalorimetry, optical methods, surface flashness, what is so these are the all the 10 to 12 questions, important questions I have measured, which is a basic knowledge for measurement and metrology students to have. Ma. So study well and do well in your examinations. Uh, so thank you, ma. Thank you for your watching. And any suggestions, please give. I will be uploading in my next